Okay guys, so today we are going to do problem 876, middle of the linked list. This was a problem of the day for December 4th, 2022, but as you can see I missed it. So in order to make up for it, I'm going to go ahead and do it now. It's 12:39 p.m. and we are going to do problem 876, middle of the linked list. Okay. So it says, given the head of a singly linked list, return the middle node of the linked list. If there are two middle nodes, return the second middle node. Just a caveat, I've already done this problem before. I know how to do it, and I've done it in Python. I've also done it in, I believe the book was Elements of Programming Interviews, EPI, the Python edition. Highly recommend it if you are going to be studying for any sort of technical interviews. Okay. So the question is, yes, return the middle of the linked list. So 1, 2, 3, 4, 5. In this case, return the 3. 1, 2, 3, 4, 5, 6. Return the 4. We return the second one in the case of an even length linked list here. So that's something to keep in mind. So as always, before jumping into any examples or anything like that, I will always write the goal. Goal is to return the middle node of the linked list. Our inputs are given one parameter, the head of the linked list. Output, return the middle, a pointer to the middle node of the linked list. Okay, so some examples as you've seen: 1, 2, 3, return 2. 1, 2, 3, 4, return 3, right? Returning the middle, and returning the second quote unquote middle if it's even. Instead of the 2, you return the 3. Okay. Let's see, edge cases. There could be one link node, so if there's only one, I'm guessing you return that one. So that's pretty straightforward. So how do we do this? I have the solution in mind, but we're going to kind of work towards it to make this more productive. The idea is that, okay, we need to somehow get to the end, and then we can work our way to the middle. If we knew how long it is, it becomes trivial, right? If we know if it's like 5, then we can just iterate 2 times. If we know if it's length 6, then we can iterate 3 times. It becomes fairly straightforward. So one of the answers to this problem is iterate through the linked list once of n time, and then iterate it through halfway times once you know the size of it. That's also O of n time. And that's also of 1 space complexity, but there is a little bit faster. We can do this in 1 iteration. If you notice that we're basically dividing the length by 2, right? So the idea is if we can have a pointer that goes 2 times the speed and a pointer that goes 1 times the speed, we can reach the end 2 times as fast as we reach the middle. Does that make sense? It's a little tricky to wrap your head around it, but once you get the trick, kind of like tortoise in the hare kind of deal, you can add it to your toolbox, and it makes intuitive sense, and you'll be able to pick it up real quick. Being introduced to tortoise in the hare for the first time, it's definitely a little confusing, but it'll make sense once you analyze it here. It's hard to come to it to that conclusion in the middle of an interview, so make sure you study it before you find that on an interview. So the tortoise and the fast and slow pointer. So we both started at the first pointer, and then on each step, the fast pointer jumps 2 nodes, and the slow pointer jumps 1. And then again, the fast pointer is on 3, the slow pointer is on 2. The next iteration, this jumps 1, and the fast pointer jumps 2. If the fast pointer ends up on a node that doesn't have a next, then we stop. And same for here, we stop. In this example, we have a fast pointer, fast, and then to slow. Come back to the fast again, fast, ends up on the 5. The slow pointer steps to a 3, and then fast can travel to the next node, so it does fast, fast, and then the slow pointer goes to 4. Oh, we don't have a fast node anymore, we stop. So the fast node stops on 2 conditions: if it's on a null pointer, or if its next node is on a null pointer. Okay, that makes sense. So that's the odd and the even case. So if node of, well, it doesn't matter what, even in the case of, in our case here, we have fast, fast, and slow is 2, fast, fast, slow, then fast, fast, slow is still 3. In this case, fast and slow, since the fast does not have a next pointer, it actually just stops and returns the slow pointer in 1, so we don't even have to worry about it. So pseudocode, fast and slow pointer. Fast goes 2 steps per iteration. Slow goes 1 step per iteration. And then stop fast and slow pointer when fast dot fast next equal to null pointer or fast to null pointer. Then just return the slow pointer. Okay, so list node slow, let's go ahead. List node fast, go ahead. Right, we have head, head. Okay, while fast and fast next, slow next, slow is equal to slow next, fast is equal to fast next, next, turn slow. So that's the very simplified version of it. Typically, we don't want to. We could use this head pointer as a slow pointer, but we usually don't want to modify any parameter values. It's very little memory just to create a new variable. So slow pointer, fast and fast next, as we talked about in the pseudocode. This should be and. Slow is equal to slow next. Fast is equal to 2 steps, so 2 next. And then keep looping that until you hit this condition. Then return the slow pointer. Before I forget, let's talk about the time complexity. This is O of n. Space complexity is constant. Why is the time complexity O of n? Because we are iterating through the list O of n times, right? We iterated through it once. The fast pointer goes through it until it hits the end. The slow pointer iterates till it's halfway. Space complexity is constant. We only allocate exactly 2 pointers, no matter how big the list is. So it's not dependent on the list. It's constant, so we can say it's O of 1. Okay. Let's think. Any edge cases. It says number of nodes can be 1 to 100. That's not 0, so we don't have to think about that edge case. And that is it. So run through. Typically in technical interviews, they'll also ask you to run through some examples for your code. So I'll do that. Odd, even, and edge. So first for the odd case, 1, 2, 3. Slow is 1. Fast is 1. Here slow becomes 2. Fast becomes 3. Oh, but 3 does not have a next node attached to it, right? So it stops, and we return 2. So that's that. So for 1, 2, 3, 4 now, we have 1, 1. Slow is going to be, the next one is 2. The fast is going to be 1 to 2 to 3. Okay, next iteration. Slow becomes 3. Fast becomes 3 to 4 to null point. So now we return 3. And of course, the single case where there's only 1. So 1, 1. Fast next is null pointer, so this stops and return 1. So we've proven it, and let's give it a run, see if we accidentally missed any semicolons or syntax errors or things like that. No, we didn't. Now, of course, we can add our test cases we just talked about. 2, 3, so that's odd and even. We can run it just to make sure that it is correct, and that is the correct. that is the case. It's all accepted. Submit the problem. And yes, it's accepted. It's 60% and 22%. Now, we're going to take a look at the solution, see if there's anything we can improve on. But I think this is a pretty efficient solution, I think. Let's take a look at Lee215. This guy has always got some interesting code, but it looks like it's exactly the same thing I wrote. So that's good. Means I remember how to do this problem. Oh, of course. Here we go to this pattern for problems that require middle linked list. Right. Same thing I wrote. Okay. So there's no other way to solve this. Sorry to digress. The new design was released today, so I kind of want to give my opinion. I'm not too happy with it, honestly, because if you look at some of this, the text boxes are really smaller. Sometimes that can be problematic. So I'm going to put a... Okay, I'll do that after this. Okay, so thank you for tuning in. That's problem 876. It's an easy question. Let's take a look, actually, at how long that took for me. 11 minutes. Considering I was explaining it, it's a pretty good time. Of course, I probably could have done it in 5 minutes, but there's that. All right. Thanks for watching. See you next time.